All right, so here we go. We're going to finish up 3.2 today. We've already looked at fat grams and calories. That was just kind of one thing that we did with the regression line. Now, this is a huge fact. This right here, find this slide. I know my slides are kind of out of order, but find that slide. This is on your formula sheet. This should be on, I think you have a blue formula sheet. This should be somewhere on your formula sheet, but you will memorize it at some point. This should be on your formula sheet. And this seems like, man, why in the world would I need a new formula for slope? You're going to use this if you get a computer printout. So if you see a computer printout and I need you to write the equation of a line, you're going to use that on the computer printout, okay? All right. Also, this is another very cool rule that you're going to need to know, but it is not on your formula sheet, okay? Every least squares regression line passes through X bar, Y bar, which means that the average of the X's, whatever it is, and the average of the Y's makes an ordered pair, and your regression line will pass through this. These two pieces of information will be used together to come up with the regression line, okay? I'll show you an example of that. We will do an example. It's kind of odd, it's kind of crazy, but this is something that could actually happen. So I'm gonna grab my computer or my little calculator, and we're gonna look at something in my calculator. Now don't forget this, on your slope, check this out. Your slope, R is your correlation coefficient. S sub y is the standard deviation of y over the standard deviation of x. Notice it's still y's over 1, right? It's y's over x's. So don't do x over y or you'll mess yourself up, okay? So there is a place on your test where you are going to have to use this example, okay, of how to do a regression line without the actual data that you need, okay? All right, so here we go. Here is one example of a computer printout. They give you this formula, okay? And we're gonna go back to, I fell. Look, hi sugars, sorry I fell. There we go. Y'all help me out. There we go. All right, so we are going to use this to write the equation of a regression line. They gave you the equation of the regression line. They gave it to you up at the top. This is your y hat, fat gain. NEA is your X, which stands for non-exercise activity, if you read about it in your book, okay? Now notice your A value and your B value. It gives it to you right here. Your constant is your A, and your slope is your B. And it always gives it to you in order. So what a blessing that it gives it to you in order. Okay? It also, we don't need this or this or this or this or this or this or this, but it also gives you your R squared. Do y'all see that? It does not give you R, and I know you don't know what R squared is yet. I'm going to teach you today. But if I wanted to know my R, I could take the square root, and obviously move this back, I could take the square root of 0.606, and that would give me R, okay? So R and R squared, they're inverses of each other, okay? So take the square root and you'll get your R value back, okay? All right, so you can see that it gives you data. What if it doesn't give you your slope and y-intercept? You can still find it using a fun formula, okay? All right, so I'm gonna pull up an example for you so that you can see exactly what might happen here. All right, hold please while I find a fun formula for you. I've got a great warm up, but I do have to find it so I can show you guys how it works. Let's see. Let's see here. Y'all give me 1 second. Let me see if I can find something that's gonna find exactly what I'm looking for.
Ashley, flip the calculator over so there's grip on the bottom so it won't fall out.
Like that?
Thank you guys.
There's grip on both sides. Oh.
Yeah, that's like
Oh, it's gonna be
Well, I cannot find that fantastic warm up that I'm looking for. Well, we might just have to wait just a second. Let's see. Okay, I have an old test question. We'll use an old test question. All right, I think I found it. There we go. All right, so now I want y'all to watch this, and I want y'all to see how those formulas work, okay? Now, here we go. I'm gonna move this so you can see. And then I'm going to, y'all need to write this down somewhere. You don't need all of the data, but I want to show an example of how to use those crazy formulas, okay? All right, so here we go. The data below represents the hours of sunshine and the number of visitors to a water park. So you can just do this in the margins, okay, or somewhere. Now, right here, they gave me a computer printout, looks like our graphing calculator, hours of sunshine, and then over here, they gave me the number of visitors, okay? Now, they didn't give me a table. I cannot put any of this in my graphing calculator, which is an issue, right? So what we're gonna have to do is, if I want you to write the equation of the least squares regression line, you can absolutely write the equation of the least squares regression line using those fun formulas. So I'm going to rewrite the formulas over here. B equals R times the standard deviation of Y over the standard deviation of X. And I'll also note that it passes through X bar, Y bar. I'm going to use these two pieces of information to actually write the equation of the line, okay? Now, over here, do you notice this is all X's and this is all X's, okay? All they did was one variable stats on both of them, so they both show up as X's. We have to determine which one is my, my explanatory and which one is my response. So which one do you think explains the other? Yeah, I would say that hours of sunshine explains the number of visitors, okay? So hours of sunshine, we're going to make this our X. And then number of visitors, we're going to make this our Y. And then they gave me my correlation coefficient R, okay? Now, these are the pieces of data that I need to know. And this is how we are going to organize this. You're going to find your B first, and then your A. And our goal is to write Y equals A plus BX. All right. All right, so you have to be a BA to get this in statistics, brilliant in algebra. Do your B before your A, okay? All right, so this is what we're going to do. Let's go ahead and highlight what we need over here and what's most important to us. I need to know my X bar So you can write down your X bar. I need to know my Y bar, which is 258. I also, looking at these formulas, need to know my R, my X bar, my Y bar. I need to know the standard deviation of Y and the standard deviation of X. So here's the standard deviation of X. We'll round it to 2 decimals. And here's the standard deviation of Y, which we'll round to 2 decimals. Okay? And now I can write my formula write the equation using the formulas. Okay? So over here, I'm going to go ahead and write that. We have B equals R times the standard deviation of Y over the standard deviation of X. And all you have to do is plug it in. I'm going to turn the lights on to see if they'll be able to see the screen better, because it doesn't look, yeah, it looks like the screen will come in better now. All right, so here we go. So my R they gave me is 0.80 times the standard deviation of Y. Remember, it's Y is over 1, 132.71. All over 3.07. All right, so I'm just using that B equals formula from your notes. Now come up with your B value for me. Come up with your B value. What did y'all get? 34 what?
0.58.
Okay, 34.58. So that is my B value. I already know it. It is positive, which makes sense because as hours of sunshine goes up, I would expect the number of visitors to go up. Okay? Now to find your A value, we're going to go back to Algebra 1. You've got to be brilliant algebraic student. There we go. So Y equals A plus BX. Now watch carefully. I already know my B value. And then what I'm going to use here is X bar and Y bar. And then the only variable left will be A, and that's what I'm solving for, right? So find your B and then your A. B, A. So my Y bar, come over here, is, they gave it to you. Y bar is 258. And now we're just back in algebra class. I don't know my A because I'm trying to solve for A. I'm in my A column. Plus, what is my B value? 34.58. And then my X bar is 5.25. So now multiply those two together. And I got 181.545. Now to solve for A, we're going to go ahead and move that over. And you get 76.46. All right, so down here, 76.46. Now you've written the equation of the line. You had to use X bar, Y bar, R had to be given to you, and you had to use your standard deviation Y, standard deviation of X. Woo!
So this is like a legit decimal line.
This is the legit least squares regression line. It is. This is exactly what you would have gotten if you would have put it in your calculator to less decimal places. Okay? So this is your legit least squares regression line. Now, can you describe your A value? That's your y-intercept, right? In context. So I'm going to get out my little cheat sheet here. Okay? My A value. I predict when hours of sunshine is 0, the number of visitors is 76.46. Is that extrapolation? Does it even make any sense? 0 hours of sunshine, and I'm going to have 76 visitors. What do y'all think? It's extrapolation. It's kind of outside of the range of the data. It wouldn't even make sense, right? It's nonsense. Sometimes your y-intercept won't make sense because it's way too far outside the range of the data, okay? There's no way you're going to have 0 hours of sunshine, okay? All right, over here, this is my slope. Now remember, your slope, you rewrite over 1 is the change in y over the change in x. My y value is number of visitors. My x value in this case is hours of sunshine. So if I were to describe that, get out my Mad Libs, right, where you fill in the blank. On average, I predict for every 1 hour increase in sunshine, the number of visitors will increase by 34.58. Okay? I know you can't have 34.58 or 0.58 of a visitor, okay, but we keep it like that. All right, so how would y'all describe your strength as a review? Strong, positive. We really don't know if this is linear or not, do we? Because we don't see a picture of it. Okay. If I were to ask you, let's see here. Let me see what we have on here. Dun, 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 dun. Find your B, find your A, describe your slope, describe your y-intercept. Okay, perfect. Good. All right, so does everybody feel comfortable with that? Now we're going to move on to more about residuals. What is a residual? Yeah, that leftover, that vertical distance from the actual point to the line, right? All right, so we're going to look at that. And then there's something called a residual plot. So in theory, shouldn't this perfect line be like dead center of all the points, right? All the dots. It should be dead center, which means when we do a residual plot, the line turns horizontal and all of these dots should be randomly scattered. There should be no pattern. So we're going to look at a residual plot today, okay? All right, let me get this out of the way and go back to the notes. All right, so here we go. So now you could have a very easy statistical output that could give you the data, or you could have a more confusing one like I just did, okay? All right, so look at your numerical summaries and see what you can come up with. All right, so here's your best fit line, okay? And it says, let's predict the fat gain for an individual whose non-exercise activity is 400 calories. Okay, it says based on your linear pattern, can you predict? Of course I can. So I'm going to go to 400 calories. I'm going to go up. Here's my regression line. Come right over, and it looks like it's about 2 kilograms of weight gain, okay? Approximately 2 kilograms of weight gain. Can I find a residual for this value? Is there an actual point at 400? Do y'all see an actual point at 400? I do. Do y'all see an actual point? Right here. So this is an actual value. And that actual value looks like 400 comma, what do y'all think? 3.8? Sounds good. And then my predicted value looks like, because my predicted value comes from the prediction line, it looks like 400 comma, I don't know, what do y'all want to say? 2.1? Sure. Okay. Looks about like 2.1. So y'all can see my residual there, and a residual, do y'all remember how to find it? Residual is actual minus predicted. You know how you remember AP? You're in AP class, right? You're an AP stat. So it's actual Y minus your predicted Y. So my actual Y value is 3.8. My predicted Y value is 2.1. So I could subtract those right there and get 1.7, and that would be my residual. It's a positive residual. Yes?
Shouldn't all the residuals on the top and bottom all add up to 0?
Yes, all residuals should add up to 0. All the residuals on the top should be positive. And then all the residuals on the bottom Since you would do actual minus predicted, it would end up being negative. So all of these should be negative down here. All the residuals add up to 0. Okay? All right, so that's how we find residuals. All right, strength, form, and direction. Make sure that you guys feel comfortable with strength, direction, and form. We've done that several times, so I think you're okay on that example. Okay, here's a different one. Check this out. Okay, so it says write the equation of a least squares regression line given this mini tab output. This is a terrible output. There's so much stuff on it that it makes you scared a little bit, okay? But don't be scared. It tells you what the dependent variable is, gas used, okay? And then down here, it gives you a bunch of data. I want you to come to where you see the word constant. And that will always be your A value. And whatever's below it, degree days, that sounds like slope. What's the degrees for the days? Remember, slope is a 2-variable analysis. It's a relationship between your y's over your 1, your y's over your x's. So this is your B value. So easy enough on this one. Y hat equals A plus BX. So Y hat equals my A value, 1.09. This is a positive plus 0.19x. So sometimes you have to search for it. I don't think we need anything called a residual regression sum of squares. Over here, degrees of freedom, all of this looks a little scary. T ratio, we don't know any of that right now, okay? We will get there, but we don't know it right now. So all we need is, we need the set of numbers under the word coefficient, okay? This is an example on your test, so just be prepared for that. All right, so now we know the residual is the difference between the observed or the actual minus the predicted. We're good there. Already showed you some residuals. All right, here we go. I think we could probably find the residuals on this one. Let's see if you guys know how to find the residuals. So let's go ahead and put this in. Temperature and revenue. Temperature and revenue. There's only 4 pieces. Go ahead and put them in your graphing calculator. Go. We're going to do several things with this. So go ahead and clear all that out. I'm going to do one of them by hand, and then obviously we can do the rest in the calculator, okay? All right, so you should have a slide with all that on it. Okay, before you can actually figure this stuff out, I'm just going to go ahead and write down a little bit of this. So my temperature, 28.2, 21.4, 32.9, 24. All right. My revenue is right here. This is all the stuff that was given to me. And these are my Y values. These are my X values. So these are my actual Y values. And if I'm trying to come up with my residual, then I also have to know my predicted Y values. It's actual minus predicted, or observed minus predicted, however you want to say it. So I have to come up with my predicted Y's. All right, so this is how you do it. You have all that data in your calculator. Go ahead and stat calc 8. To find your predicted Y's, you got to know your prediction line, right? So you've got to come up with your prediction line right here. So let's go ahead and figure out what our prediction line is. So stat calc 8, My prediction line for this is negative 14.09 plus 1.84x. Now this is my prediction line. So if I want to know my predicted Y values, if I want to know that Y, what am I going to have to plug into my prediction line to get a predicted Y value back? You have to plug in your X. Okay, so here we go. You're going to take this X right here, and instead of the actual Y, you're going to plug it into the equation. So I'm going to plug 28 in. So I have negative 14.09 plus 1.84 plug in that x, 28.2, and it will give you your predicted y value back. And I got 37.798. Did y'all get something like that? Yes? Okay. Now, you still haven't found your residual. The only thing you found was a prediction line and your predicted y. Now, if you want to find your residual, then you have to do your actual y minus your predicted y. Remember, it is AP, actual minus predicted. So I come over here. I'm going to do my actual y was what? 44. I'm going to take away from that the 37.798, and then that will give me how far off I am. And I got 6.202. Are you there? Do y'all remember how to find residuals in your calculator? Okay, I'm about to show you so we can compare our answer. Now, my answer is going to be a little off, not because we're bad, but because we rounded this and we rounded that, right? We rounded two different things. So, if I want to know my residuals, this is what you're going to do. Go to Stat. Everybody press Stat. Then go to Edit. Stat and Edit. I'm going to click out of this even though it might look crazy. Okay, so Stat and Edit. And I'm going to zoom in on this real quick. All right, so here's my data. Oh, that is a big glare. Okay. See if y'all can see it. All right, so Stat and Edit. Now, I want you to highlight L3. So highlight L3. Now, you must have ran a regression line from here. You had to have StatCalc 8 before you do what I'm about to show you to do. It has all the residuals stored in there for you, but it doesn't know a residual until it knows all of your predicted y's. It can't come up with your predicted y's until you run a prediction equation. So you've got to StatCalc 8 first and come up with this prediction equation, which is stored in your calculator. Then you can come over here, and if you want to know what your residuals are going to be, there's something called Resid, and it's under List. So highlight L3. So L3 is highlighted. Then go to your List button, which is right here. It's above Stat because it goes with statistics, okay? So where it says List, I'm going to do second, then press the List button, and go all the way down until you see the word Resid. Press Enter, and it's saying, do you want List 3 to be List Resid? Absolutely, please. So press Enter again, and there are all of your residuals. So they got about 6.09, about 6.1. We got about 6.2 because I rounded both of those up, okay? Obviously, calculator's more accurate, but those are your residuals, okay? All right, now, here's the next thing that you should see somewhere in your notes is something called a residual plot. So get out your cheat sheet from yesterday, your little graphic organizer. Get out your graphic organizer cheat sheet, and I'm going to teach you a new rule. So underneath the residual, we are going to write about residual plots. This is in your notes. Here is the rule. All right, your residual plot, no pattern, means you have a good fit line. It means that a line is a really good fit. You looked at the data, you looked at the scatter plot, you said, yes, I think a line's going to really fit that data well. So then you fit a line to it. So you had to have StatCalc data already for all those residuals to be in there. But if we see no pattern, that means we have a good fitting line. It means that a least squares regression line is a really good fit for it. Now, how do you do a residual plot? It is L1 in your X list. And in your Y list, it's just another scatter plot, is residuals. So it's going to take all your X values, plot them with your residuals. Obviously, some of the residuals will be positive, some of them will be negative. And when you graph this, you should see no pattern equals good fitting line. If there's a pattern, like if it looks parabolic, if it looks like a parabola, then you probably should have done a quadratic regression instead of a linear regression. Okay? So whatever pattern you see, if you do see a pattern, that's probably what would fit it better. Okay? So here we go. Let's do it. Get out your calculator. We have data in there right now. This is what I want you to do. Go to stat plot. So we're going to do a scatter plot. I'm going to turn my plot one on. I'm going to do a scatter plot. And instead of L1 and L2, this needs to say what? What did I tell you it needs to say? It needs to say L1 and resid. Where do I go to get that resid thing again? Where did you find it before? List. It is a list. It says Y list, so you just press the list key again. And go all the way down. And it should say L1 resid, L1 resid. Got it? Zoom 9. All right. So it's hard to see a pattern in this anyways because there's only 4 pieces of data. Okay? But this is what it should look like. Here's your x-axis, non-exercise activity. Here's your fat gain, gain, loss, stayed the same, loss. Okay? So this should look fairly scattered. I'm going to show you some that don't look random. Okay? So it should look random with no pattern. So that means this is a good fitting line, that the line fits the data well. Okay? All right, so that's how you do a residual plot. So if I ask you if the line fits the data well, now you know. All right, back to your notes real quick. We are getting done. I know today's a long day. You're okay. Tomorrow will not be as long. All right, so here we go. We already did that. Again, a residual plot, no pattern, means you have a good fitting line. Here is a great residual plot. I do not see a pattern at all on any of these, okay? No pattern, good fitting line. All right, let's try another one. All right, so like I said, well fit. If there's a pattern, it means that a line's not the best model. All right, so here's one right here. Do y'all see how this is almost, it's like a wave. Do y'all see that? So a sinusoidal, a sine regression might work better for that. Yeah. This is a great one. No pattern, good fit in line. This one, not so much. This one kind of spreads out along the way, so it almost looks like, yes, really fits the data well there. Tiny residuals means all the dots are really tightly packed together, right, on your scatter plot because there's hardly any, but then it spreads out, so fits it better at the beginning. All right, so I want you to put this one in, and I want you to tell me if this is a good fitting line. This should be in your notes somewhere. I don't know if you can read it in your notes. Bless you. Bless you. All right, get them in. Once you have them in, I'm going to get out of the screen so I can show you what happened on this one. I do not know what this data stands for. It's not necessarily in order. Make sure you have it all in. When you have it all in, smile at me through your mask. Okay, I don't hear much typing. Am I good? Good, good, good. Okay. All right, so here we go. Looking at this data right here, let me make this a little bit bigger. There we go. All right, so I have my data right here. I'm going to go ahead and clear out list 3. All right, let's do a scatter plot on it and just see what it looks like. Do L1 and L2. That's a regular old scatter plot. Zoom 9 on that regular old scatter plot. Holy moly! What is going on there, y'all? Does it look like a line is a good fit for this? Do you see a curved pattern in this? Okay, that means you will see a curved pattern in your residual plot. Can I do a residual plot right now? Shake your head and say no. Have I done StatCalc 8 yet? So there's no regression line, there's no residuals, there's nothing in there right now. Okay, so first we have to do StatCalc 8 and come up with that. So go ahead, StatCalc 8, L1, L2, calculate. Your R doesn't really tell the whole story here, does it? 0.81 kind of looks strong, but would a line fit the data well? No, not at all, okay? So now that I have that, I want you to go back and let's do residual plot. So go back to stat plot. You don't even have to put the residuals in a list unless you just want to see them. They're already there. So now I'm going to change this to L1 and resid. Okay, you don't have to put them in list 3. They're already there. So go to list, go down, and here is L1 and resid. Okay, now zoom 9. And there's almost the same pattern. Do y'all see that? So since there's a pattern, does a line fit this data well? Not at all. Okay, very good. Now, the very last thing that we're going to cover today is coefficient of determination. So let's go ahead and find the notes on that, and then we'll be done. I know it's a long day. Suck it up. You can do hard things. All right, here we go. All right, I'm going to go through this one pretty quickly. It's not too bad. All right, your coefficient of determination is, all right, it's R squared. Now, R squared has a crazy formula. You'll never have to use the formula on R squared. You do have to understand what it means, though, okay? So I'm going to give you my best example. It's kind of the same as the AP Stat guy gives. If you haven't watched that one yet, the pizza example. My very first job was working at Little Caesars. Thank you for calling Little Caesars on Killian Hill in 78. Would you like takeout or delivery tonight? That's what I said every night, okay? We used to make all sorts of specialty pizzas. I don't think Little Caesars does that anymore. But I'm going to give you an example of what R squared is, okay? It is the amount of variation that is explained by your regression line. Here is your Mad Lib sentence. We will write it on our cheat sheet in a second, okay? It's going to give you a percentage. R squared is a percentage of the variation in the Y that is explained by the regression line that relates Y to X. How much does your line explain the relationship between X and Y? Here's my example. Here we go. So I worked at Little Caesars. Now these days at Little Caesars, it probably looks like this, okay? Number of toppings and price is probably linear, right? You start, it's $5 for a pizza or however much it is. And if you get one topping, then it's $6, right? And if you get 2 toppings, then it's $7. And if you get 3 toppings, it's $8. And so it makes a perfectly straight line. Your R squared there is 100% or 1. Your R is also 1 because it is a perfectly straight line. Unfortunately, we don't all go to Little Caesars, right? There are some other places that have much better pizza maybe, right? What is one of your favorite pizza places? Little Caesars? That's it? Okay, what did you say? Okay, Leopoldo's. Okay, Fede, is it still open? Maybe? Okay, so he runs that one. All right, over here, one of my favorite places is Fabiano's. It's in Noonan or Douglasville. Has anybody ever been to Fabiano's? So good. All right, so it's on the square in Noonan and Douglasville. So Fabiano's has a lot going on other than just toppings and price. So would you agree that there are other things that could cause your price to change other than just the number of toppings? Crust. What if you get thin crust, thick crust, pan, stuffed crust, all that, right? But is crust one of my things right here? Type of crust is not listed. It's called a lurking variable, right? What's another type? What could happen? Size of your pizza. Big difference. What about sauce? What if you got like a chicken Alfredo or a buffalo chicken pizza, right? Or pesto. So there's all different types, but sauce isn't listed here, just number of toppings. Also, could the number of toppings vary in price? Could you have like the 50-cent toppings, but then you have caviar and you want $2 toppings if you put anchovies on it, that type of thing? Okay, so they could have all different prices. So number of toppings doesn't quite explain everything about your price increasing, okay? So it's a little bit more scattered because not everything is listed. There are lots more variables that go into explaining why than just the number of toppings. Crust, size, sauce, right? Type of toppings. So there's a bunch of different things that are not listed there. So you'll get an R-squared value back. That R-squared value tells you the variation in Y that's explained by your regression line relating Y to X. So if I got 72%, let's just say 72. If I got 72% back, 72% of the variation in price is explained by the regression line that relates price to toppings. That means that somewhere out there I have 28% that's a lurking variable that would explain the change in price. But I couldn't graph it on here because it's just two-dimensional, right? Okay. So that R-squared, it's a little odd, but like I said, it's just the amount of variability of Y. So as Y changes, how much Y is changing based on this X. But Y might be changing based on some other X's that aren't graphed. Okay? So that's your R-squared. All right, so here we go. R and R-squared. Be careful because R-squared is always positive. Because when you square a number, it's always positive, right? If I asked you to find R, R is the square root of R squared. But can't R be negative? So if I give you your R squared, and you take the square root and get your R, you still need to look at your slope or look at the graph or look at something to see if R should be positive or negative. Because when you take the square root, it's plus or minus, right? So be careful on that, okay? So be careful when you take that. You have to look at it. Again, make sure you know your Mad Libs on R squared, okay? All right, a few things that you need to know. R, again, and R squared do not distinguish between explanatory and response. We already know that, okay? Obviously, there's a close connection between correlation and slope. Here is your slope. Here's your correlation. So make sure that you're watching after that. And obviously, these are all affected by outliers, okay? Your least squares regression line always passes through X bar, Y bar. Correlation describes the strength of a straight line and not of a curved line. Your calculator will give you an R and R squared even if it's a crappy R and R squared that doesn't really fit if you have a curve in your line. Okay? All right. I think I'm about done. Tomorrow, we're going to cover 3.3, which is just like precaution stuff. It's a very short chapter or lesson. If you look at your notes, you don't have that much left in your notes, okay? Friday, we review. Monday, we have a test. All right, I'm done. And you still have 25 minutes. Woo! All right. Have a good day, y'all.